Okay. All right. Hope you guys are having a good show. Want to talk to you about HPC Cloud ROI. Turn it down just a little bit. Awesome. Thank you, Jared. You're always so helpful. Want to talk about HPC Cloud ROI and opportunities that Cloud brings to HPC. So, just wanted to outline Adaptive's experience with working with cloud customers and working in the HPC industry for a long time now, and how we see the convergence and some commonalities and some differences that have occurred, and what this means to the HPC industry. So this is what the old way looks like to a typical organization. You have the development staff with their different projects, your QA, your IT infrastructure, support, etc., all segregated and siloed, right? And this is a pretty simple problem that HPC solved a while ago, but there's some different things that have happened with this infrastructure. You have the inefficient use of resources, where resources are being left idle. You only use as much as what the spike allows, and then it goes back down, and you're not using a lot. You have the reallocation of resources is difficult in the siloed environment, because you have to keep track of who's purchased what, who was promised what. Actually having to physically remove servers or move them to another location. And then also, if one team or one budget or project handles purchasing the hardware, do they keep the hardware throughout the life cycle of that hardware, or does it get passed on to a centralized source? So the thing about this that's interesting is that we've actually seen scenarios where people have been fired for not following what I'm about to recommend to you. And so what I'd like to have happen is I'd like to be able to say, hey, as you're rolling out cloud technologies in your HPC space, or considering what cloud means to your HPC site, we want to be able to say, hey, to your stakeholders and to your site, some pretty amazing things have happened, if not miracles. So the new cloud solution is really all your projects are sharing the same resources. So you have development, QA, support, IT, and others can share the big pool of resources. Sounds like an HPC cluster to me, right? So the thing that we found is that a lot of the problems that cloud is trying to solve in the enterprise are things that the HPC industry has solved a while ago with different projects sharing the same resources with batch workload. So I'm going to start off, before I talk about public cloud, by talking about private cloud best practices, because that is often what we see with our customers. The large percentage of people that are interested in cloud technologies want to be able to roll out cloud in a way that takes advantage of their HPC best practices, and also the beefy hardware that the HPC sites already have. So these are in priority order. These are priority according to myself and Adaptive. You can roll these out or consider these in the priority order that makes sense for you, but we found that the common priority is the one that I'm about to describe. So one, you want to focus on ROI. So the ROI is the foundation of all of your decisions as you assess what you're going to do with your stack. And I'll be talking about what the stack looks like towards the end of my presentation. Two, you want to be able to facilitate self-service. Three, you want chargeback allocation and accounting. Four, you want to be able to continuously optimize. I'm standing in Adaptive's booth, where this is our forte. And five, this is more of a political best practice, that when you decide to roll out any technology or any change to an organization, you want to be able to go vertical within a single group before you broaden it out to the entire site. So let's start breaking down these best practices and what they mean, and how you address them. So with the first one, focusing on ROI, a lot of people consider ROI to be a simple buzzword, but really you should actually consider its origins, right? It's your return over your investment. So as I approach the other best practices, consider how this best practice increases your return while reducing your investment, right, to get you the highest ROI possible. So what we've seen in ROI metrics when we're dealing with private cloud is often we see services, which again is a little bit of a unique situation for HPC customers, but a service really is a request for a certain amount of resources, and I'll talk more about that in just a moment of what that means. But we've seen things get deployed 10 to 100 times faster from initial request of resources to a centralized IT staff or system administration team giving you the resources. We've seen an increase of savings to 2 to 10x of hardware, where you don't have to purchase as much hardware, as well as IT staff being able to focus on your business problems instead of the problems that lead to solving more problems instead of solving your business. So some general ideas here. I'm going to be focusing on how you calculate ROI at the end of my presentation to give you some greater foundational building blocks to help tailor to your site. Second of all, you want to look at facilitating self-service. So HPC has been doing this for a long time, right? You have a self-service portal that deals with job submission. This is a really basic tenet of HPC, where your users will come in, they'll ask for a certain amount of resources, they'll specify a job script, and away they go. They've tapped into your site. Well, with cloud, it's all that much more important to have this building block in place, because with cloud you might be bursting out to a public cloud, you might be dealing with an abstraction of resources that typically in an HPC site your end users actually have more of an intimate knowledge of what they're using, whereas in a cloud, the term cloud comes from this concept of you don't know where the resources are coming from or what they look like. So I've run into sites that offend this best practice by saying, hey, my guys are command line people, we don't need this. But then what happens is, if you don't have this abstraction layer there, when you go to roll out cloud technologies, you're going to run into some pain. On top of that, and this is what makes Adaptive unique, is that if you build out a self-service catalog, you're going to be tapping into existing HPC concepts. So what I'm showing you here is our service template and our workflows, which in HPC speak is really about job dependencies, which, you know, in the HPC space you often deal with workflows that have thousands of steps, right? So in this case here, the scenario is you could have a use case where you have the first step is to request your resources, the second step is to test your resources are set up correctly, third step is to stage your application, fourth step is to stage the application data back, fifth step is to decommission those resources. So within that step process, you have a workload that you're executing that you'd see typically from your application, but it's wrapped and abstracted into this request process that is called the service request. So the third best practice is to use chargeback. So again, allocation management and chargeback and accounting have existed in HPC for a long time, but a lot of sites, they typically think that they don't need to use this unless they're dealing with a severely political environment. But again, the problem with this and the shortcoming of taking this approach is that when you go to roll out cloud technologies in the HPC space, it's like kids stealing cookies from a cookie jar, right? Where as soon as you have a good thing going, you hand them over the cookie jar and people are just going to take as many as they can until they get sick, right? So what the allocation and accounting and chargeback does is it allows you to add governance. So you have the political landscape and the economic landscape built into your solution. You decrease the overuse, and you reduce any waste, right? So typically what we see is sites and users of resources will be super optimistic with their resource requests. And what I mean by this is they'll think in their mind, okay, if my project is really successful, I'm going to need this many resources. But what happens is that in order to get their project off the ground, they need to be able to test it out in a much smaller space. So it leads to this dedicated versus utilized problem that is extremely out of whack. So this is a feedback loop that allows your users to self-govern themselves. So again, something that has existed in HPC for a long time, but if you go to roll out cloud, it's gonna cause you problems. And in fact, speaking from personal experience, we've had to rent cloud services for our testing purposes. And when I go to hand out my credit card to the team, you know, unless I go and govern that project very closely, it could lead to over utilization. So I've had some personal experience in-house at Adaptive with some of these challenges. So this is really obviously our bread and butter. So I want to talk about some different things that that cloud is doing within virtualization, and this is going to lead to my discussion about public cloud. But basically, using the HPC concepts that are built into our products or into other optimization layers, you can do things around workload-aware packing. So basically, your optimization layer can take all the different disparate workloads and condense them down into the tightest amount of resources possible. So what this does, first of all, is it increases the utilization of your existing systems. Then the second step from that packing is to be able to turn off those idle systems that you typically don't have being used, right? So this cuts down on your utilities, and your operations costs, as we all know, can be very costly. On top of that, going back to the use case that I've just described, where you have users who are asking for more resources than they need, we have this concept of overcommit packing where you have the requested resources versus what's actually utilized. So your optimization layer can actually basically fool the system or tell the system, hey, you're asking for 2 to 4 times more than you actually need. I'm going to turn you down, and then using technologies like thin provisioning allow you to scale as you need. So everything I've talked about, it packs it really tight, but then on top of that, your concern is, well, I want my SLAs to be able to be satisfied. So I'm packing it even tighter, which leads to even more servers being idle. But if your project that I talked about does ramp up to the size that your customers or your users are dealing with, then your optimization layer can deal with those SLAs and actually move it to a resource so the load will go back down. So the initial phase, to review, is to pack it tighter, to turn off those resources that you don't need. Then as SLAs are being, you offend those SLAs through load or throughput or other metrics that you define for your site, we can move those back to increase the utilization and those SLAs. So it's a balancing act, right? And you need your optimization layer to be able to enforce that. If you try to do this manually, there's no way you can keep up with the ability to balance resource utilization while the political landscape of application performance. So the next topic is, well, what about needed silos, right? So you have this concept of packing things tighter and tighter, but there's a political landscape. You need to have dedicated resources for security purposes or for data locality for data-intensive computing. And so with your optimization layer, it allows you to continuously optimize while also handling things through a resource pool. So what you have here is you have Project X and Project Y, and in this slide you have Project Y using the system, but all you need to do is you take your optimization layer and you explicitly specify that certain amount of resources are reserved for another project. And your optimization layer, as you can see, moves it out of that dedicated resource pool for another project. So this allows you to take your physical provision or your virtualized workload and move it for another project to have dedicated access for an important project or for resources that they purchase through their own budget. And then obviously they can submit directly into it. And the other workload does not get into that space. The next scenario that you deal with is this concept of if your IT staff needs to be able to take servers down. So basically you would define a resource pool that nobody has access to, and your optimization layer is smart enough to be able to move that workload without any disruption to their work. Okay, so I've talked about these different building blocks, and so the next step is, well, okay, Brady, that's great, but I'm interested in the cloud technology. So what about public clouds? Everyone's been talking about EC2, people are talking about Rackspace. And the nice thing about the best practices that I've laid out at this point is that they all build up to this concept of being able to treat your public cloud as a simple resource pool, right? So the brilliance of this and of this abstraction is that to your end users, it doesn't matter, right? You request resources, and on the back end, I've cut this scenario down. So there used to be five racks of nodes. I've cut it down to 3, and you can see that the system, for all intents and purposes for Project Y, is completely tapped out. So what you can do is, with the resource pools, you actually can simply call it to a public cloud and have your workload be running out there. So obviously, in this hybrid cloud use case, you do need to plan for public failures, right? You need to make sure that any system sensitive data that might be residing on the public cloud has some sort of failover policy internally. And that's something you need to work out from an application-specific perspective. But the point is your optimization layer, using those resource pools that I just talked about, can combine those workloads of cloud bursting with their typical HPC batch workloads and the service requests that I've talked about. So really, the brilliance of this is abstraction away from all the different types of workloads that you have to use a centralized data source, cuts down on the political landscape, cuts down on the need for servers. So in order to handle this, this is something that HPC really needs to learn from the enterprise cloud space, is that you have the need for well-defined APIs. So a lot of times I've found the HPC solutions have a really difficult time of defining well-abstracted APIs, but each component in your stack that I've described needs to be treated as a black box. So as you extend and you integrate your site-specific business logic into the solution, you need to be able to integrate whether it's a portal or a certain charging algorithm or bursting out to a cloud or application-specific expansion. You need well-defined APIs. So here, we at Adaptive recommend things like REST APIs and other mechanisms to be able to roll out your cloud use cases in your HPC environment. So that's another thing that we can learn from the enterprise cloud space. So just what I want to highlight from this Uptime Institute survey is that, while people are using public cloud, there's still a lot of fear and uncertainty with using it. So that's why we recommend, and the numbers support this, is that people are much more interested in proving out cloud technologies locally inside their own IT staff and with their own data centers or clusters. And so I just want to highlight that this is another thing that we can learn, is that large organizations are leading the charge, but if you're small organizations, test this stuff out in-house just to work through the kinks there. So lastly, I just wanted to highlight one of the more the political things that you deal with when you're rolling out these types of solutions, is to go vertical and not horizontal. And what I mean by that is that you want to be able to roll this out into small chunks that are manageable by the people who are making these decisions. So before I go into that and go back to the best practices, I want to highlight what's in a cloud stack, right? So first of all, you have your basic foundation of automated provisioning, which will allow you to either handle provision bare metal machines directly or have virtualized workloads. Obviously, a lot of HPC workload with the I/O intensity that's needed. Virtualization doesn't work completely in all scenarios, but still a provisioning manager is needed in the use cases here I'm describing. On top of that, you need the service catalog to be able to abstract those provisioning requests into a way that the user understands to get their work done. Then when you get those pieces in place, you want a monitoring tool or multiple tools to be able to bubble up that information. And this is a must-have for the optimization piece, which sits at the top. Then on top of that, you need to have your accounting and charging, which uses those metrics to determine, a direct correlation of money or some abstraction through credits against system use. And then last is your policy-based optimization, right? And that's where we believe the real savings come. And I'll be talking about the ROI in just a minute. So using that stack, coupled with the best practices, you have an end goal where you want these to be rolled out across all of the groups, right? But we've seen in Adaptive, people who are really gung-ho about adopting the latest and greatest stuff, they typically are technology liberals, as I like to call them, where they're very accommodating of new trends. But what happens is we often see people who are really excited, or their forte is in these more technology-specific areas, and they do things like this, where they roll things out to the entire site. And if you look at this particular scenario, if you don't have monitoring, you don't have accounting, you don't have optimization, people are going to overuse the system. And we've actually seen scenarios where people are claiming victory with implementing cloud but it actually is significantly more expensive than the old way they did things. So, going back to building vertical instead of horizontal, you want to roll your entire stack out into a single group, prove it out, and then roll it out to everybody. And then that way you guarantee success, and you make sure you're cutting down on some of those bad behaviors using the system. So using the cloud stack technologies that I described, the same thing applies to these particular best practices. You're going to want to roll these out in the same manner. So the best practices combined with some of the experience we've had leads us to be able to talk about numbers in a more concrete way. So there's a leading global bank that we deal with, and these are their numbers where they actually are able to have the lowest cost of virtual VMs in the industry. They have greater efficiency. They have for servers and storage. They have 50% reduction of their personnel, and they're actually looking to combine their HPC and their cloud workloads into a centralized system because they've had such great success. And so, summarizing everything that I've talked about with best practices, with the real-world experience we've had of people succeeding as well as failing, really, what does cloud teach us? Cloud teaches us to use long-standing HPC concepts that some of us may take for granted, and to really roll them out in a cloud environment. So this is the self-service that you typically have seen from job submission, using the service catalogs, chargeback that you see with allocation and accounting management, rolling that out, scheduling software such as Adaptive's Moab product, and being sensitive to the political landscape. These are things that a number of us have already had lots of experience in HPC, and as we look at cloud, it's reinforcing the things that we already know, but expanding them out into a more powerful technology to be a greater utility. Also, what it teaches us is that you really need to boil this down into a basic ROI calculator. So this is a basic way of looking at how you can assess return on investment. So you can look at the number of servers, the number of VMs that you have across your system, what it costs to maintain these different servers, and the number of OSs and infrastructure across your solution before you roll out these best practices and after, right? So basically you come up with this number that's the efficiency factor with the solution, and then you apply that to your servers and your VMs, and that gives you the total amount of cost that you're saving from your solution. So this is kind of a basic foundational building block as you assess how you want to proceed with cloud technology. Other than that, you can reach me here. If you have any questions, we have the booth here. Thanks for coming.